Square roots. All right. So I mentioned several things yesterday about radicals, not realizing that you didn't know a lot of things about radicals. So we're going to talk about them today. Okay.
Square roots.
First of all,
What's that?
did you say what's that? Yeah, go ahead. Tell me what a square root does.
It basically divides it in half.
Close, not dividing it in half, but telling you what? What number times itself twice gives you what's under the radical? Guys, I'm going to need you to pay attention. I feel like everybody's a little chit-chatty today. I know y'all are excited about the game tonight and everything, but
No, we're not. I'm not.
all right. Are y'all ready now?
Yes, ma'am.
Okay. We talked about yesterday how the square root can be what? Positive or negative, right? So we indicate it with a plus or a minus. And why can it be positive or negative?
Because negative 2 can also go in
Because what times itself twice gives you 4? Well, negative 2 times negative 2 is positive 4, right? Okay. So then, and if I need to expand on anything a little bit more, let me know. So then we talked about, and I think I kind of confused some of you whenever I did this, so I thought we'd spend some time today talking about simplifying radicals.
So like the square root of 5 and the square root of 10.
Right, but you're right, you could break it up that way. One of the properties of radicals is that if we have two things being multiplied together under this radical, I can break them apart and write them like that, right? So what we do when we simplify radicals is we find the biggest perfect square that we can divide this number by, and then we break them apart, okay? Perfect squares, though. So think about your perfect squares. 2 squared is 4. 3 squared is 9. 4 squared is what? 5 squared is
25,
6 squared,
36,
7 squared.
49.
It's not obviously not going to be any bigger than that. So of that list, is there one, and we want to take the biggest one that there is, that we can divide 50 by?
25 and
What?
Which one goes into 50 evenly? 25, right? 25 times what?
2.
So by this property of radicals that I just told you, I could split this up as the square root of 25 times the square root of 2. Do you agree with that?
yes.
Yes?
And then you could go even more.
Well, the square root of 2 is an irrational number. It doesn't break down any further. We can just leave it. So what we'll do, we'll say this is, don't forget that plus or minus because I'm taking a radical. Square root of 25 is 5, right? And the square root of 2 stays.
I remember doing that.
This is an exact answer as opposed to, like whenever we talk about fractions and how it's better to leave it as a fraction than to estimate as a decimal, same thing here. It's not an estimation, that's an exact answer. But we definitely want to simplify them down. Let's try it.
So this is what we're going to be doing this today?
Some, yes. We're going to be solving with radicals, but you're going to have to apply these properties when we solve them.
Okay.
Okay? All right. Let's do another one. See if you can figure out how that simplifies. Let me pause this while you... All right, what did you find? What's the... No? Not ready? You got it? What's the biggest perfect square you can divide 72 by? 36. 36 times what?
2.
Do we gotta do that? Or we can do the other, do like 9 and 8 too.
Okay, so I'm going to show you with the 9 and 8 what happens. If you did 9 and 8, what's the square root of 9? 3. Now look at the square root of 8. What do you know you can divide that by?
4.
4. So I could make that 3 and then 4 and 2, right? Exactly. The square root of 4 is 2. What's 3 times 2?
6.
That was more work.
Oh, yeah.
Well, it is more work, but it's nice to know that if you don't pick the biggest one, it'll still work. You're not going to get it wrong. You just have to keep checking for perfect squares. If you take the biggest perfect square in the beginning, it's just one step.
Yep.
Does that make sense to everybody?
Yep. The biggest one every time.
Okay, biggest one every time. What if I did this? Going a little backwards here. This 21, yeah. Square root of 6 times square root of 21.
You want us to do it backwards?
Well, what would you do if I asked you to simplify that?
Do the same thing.
Well, there's not a perfect square that goes into 6, and there's not a perfect square that goes into 21.
Multiply them together.
Multiply them together. What do you get?
126.
126. Now, is there a perfect square that goes in there?
Yeah.
Maybe.
No.
Yes.
Wait.
Check and see. Use your calculator.
There it is.
Think about your list of perfect squares. 2 squared is 4, 3 squared is 9, 4 squared is 16,
5 squared is 25.
36, 49. What am I at? 6, 7, 8, 9, 10. Does anything go in there?
Nah.
Yeah, what? 64? I'm hearing 43 and 11, but what's the problem with those?
Nah. Okay.
Those aren't perfect squares. It's got to come from that list of numbers.
9. It's 9.
It's one of them, yes. 9, it's 9, yes. What times 9 gives you 126? 14. Does that make sense to everybody, simplifying radicals?
Yeah, sure.
What about, let's change it around to a fraction. Oh my goodness, y'all.
Okay, do it decimal.
So I told you that the square root of xy is the same thing as the square root of x times the square root of y, right? So in the same, close, not times, but divided by. That's right. If I can break them apart with multiplication, I can also break them apart with division. So I get the square root of x divided by the square root of y. Dang, are you taking notes back there? Yes? So if I wanted to simplify this one, what could I do?
7 divided by the square root of 16.
Which is? 4. Yes, square root of 7 over 4. So hopefully, at some point in your math career, you have learned several things about radicals
I remember doing this.
and several rules about radicals that can't happen. Tell me one of them you may remember.
Repeat that.
Things that can't happen with radicals. Yes, Sierra? Absolutely. That was the one I was wondering. You cannot have a radical in the denominator. Do y'all remember learning that? Sort of. So let's set up a scenario where we do have one in the bottom. Let's say that fraction was flipped and I had the square root of 16 over 7. Ooh. I can't have a radical in the bottom.
So then it's just not solvable.
Oh, but it is. We're going to do something special with it. Do you all agree
So we're gonna
that we've got
square-
4 over square root of 7? Now, I want you to think about this for just a minute. If we need to get rid of the radical, I want to think think about something I could do to it to get rid of it. Multiply top and bottom, yes, by what?
The square root.
The square root of 7. And you're right that you square it, you're doing the same thing.
That's what I said earlier.
Squaring it. Squaring it is essentially, remember what squaring does, it multiplies it by itself. But because this is a fraction, as long as I multiply the top and the bottom by the same thing, it's like multiplying by what? 1. Absolutely. And I can multiply anything by 1 and it keeps the same value, yes? This is what we call rationalizing the denominator. Rationalizing denominator. So see, I was right. Y'all did know some of this. All right, so
It's going to be 4 square root of 7.
correct. Over, what's the bottom become?
1. Over 7?
What's the square root of 7 times the square root of 7?
1.
7,
Oh, I see. Okay.
right? Square root of 49 is 7. Right? Think about it. The square root of 2 times the square root of 2 would be the square root of 4, which is 2. Right? The square root of 5 times the square root of 5. I can put them together and get the square root of 25, which is 5. When I multiply it by itself, does that make sense?
Yes.
Let's do another one.
Let's do it.
We ready, right? We ready?
I guess so.
You try this one.
Thank you, Ella.
Simplify that fraction. I'm going to pause the video. Some of you are saying, I think. Some of you are saying, wait another second.
Wait, I got it. I don't think I got it.
What'd you do first?
Wait, I said, you multiply it. Wait, no, you put the little square root 5.
Split it, right? Good job. The problem now, none of those radicals split up, but the problem is I have a radical in the denominator, so how do I get rid of it? I think y'all are saying the right thing, you're thinking the right thing, but you're just saying it wrong. Square root of 2, top and bottom, right? Because that's going to get rid of the radical in the bottom.
And then square root of 10.
Good job.
And then 2 will be on the bottom.
Can I reduce that to square root of 5 over 2?
Yes. No, you could.
No, because the 2 is not under a radical. So you leave it. What I was saying everybody always wants to do is they want to say, oh, well, look, I can divide both of those by 2 and get the square root of 5 over 1. But you can't do that because the 2 is not under a radical also. All right, let's talk about what if, now here's your more advanced concept that I'm going to assume that you have not seen before. What if I had something like that? I've got a radical in the bottom, definitely cannot have a radical in the bottom.
You gotta do both with multiply both the numerator and denominator by square root of 2.
Okay, so let's see what happens whenever I do that. If I use the same thought process that I used with the earlier fractions, if I do square root of 2 and square root of 2, then I get 3 root 2, and on the bottom I get 7 root 2 plus 2, because this has to distribute to the whole bottom, right? Oh, now I still have a problem, yes?
Oh, and then it repeats itself.
Okay, so you say, you are so dangerously close, it's not even funny. You said multiply by everything in the bottom? Okay, let's try it and see what happens. 7 plus root 2, 7 plus root 2. And I'm not going to worry about the top. I'm going to just do the bottom right now because that's really what we're concerned about, right? All right, 7 times 7, 49. Plus 7 root 2, plus 7 root 2, plus 2. I still got radicals in the bottom, yes? Think about this for a minute because technically you have seen what I'm fixing to show you One way, this is just a little bit backwards.
Oh, subtract.
You got it! All right, look. Ozzy says subtract. Do this on your paper. Multiply those two binomials out there and see what you get.
We're done with it. No, you don't.
49
Yeah, you do.
minus 7 root 2 plus 7 root 2 minus 2.
So there's a 7.
This is the factored form, get ready for it, of a difference of two squares. 49 minus 2. 2 is not a perfect square, but if I think about taking the square root of each end,
But you won't have to do it in the way.
but I'm just getting to the point that you have technically seen it before. It just takes a little bit deeper thinking there. Yeah.
Oh, we didn't do the making our numbers today?
Not today, no. We will get to those. Maybe tomorrow.
That was it.
Huh?
Some of the problems with involved.
Yeah, I'm rearranging it just a little bit. I moved them around a little bit yesterday. I'm gonna move them around again today. I apologize.
The square root thing
All right, look, if you don't understand that just yet, I promise we'll do so much with it that you will. But what I do want you to see is here, whenever I change the sign in the middle, it makes those radicals go away, okay? That is what we call, whenever I have something like 7 plus root 2 and 7 minus root 2, those are called conjugates. Okay, and all it does is change that middle sign. So if I had 5 plus the square root of 2, what would the conjugate of that be? 5 minus square root of 2. If I had 8 minus the square root of 3, what's the conjugate?
8 plus square root.
Do you see? So because I have to multiply top and bottom, when you have something that looks like this in the denominator, what you want to do is multiply the top and the bottom by the conjugate. I'll put that over here for you so you have it in your notes. Multiply the numerator and denominator by the conjugate. Running out of room here. All right, so let's look at the top. Distribute that 3 through. 3 times 7 is?
21.
21. Good job. And then minus, that was in the original problem.
Wait,
The original problem was 3 over 7 plus root 2.
the work before, was that like for the denominator?
Yes. I had just multiplied the denominator together because it doesn't matter if there's a radical in the numerator, only if it's in the denominator. So we were just trying some different things to see what would get it to go away. All right, let's look at the bottom. Do I need to multiply that out again? I had it on there a second ago. What did we get? 49 minus 2, and 49 minus 2 is what? Yes or no? Does that make sense?
Kinda.
Kinda. Let's do another then. I'll wait. It really starts to get tricky whenever you have a what looks like the denominator, the 7 plus root 2, whenever it looks like that in the top and the bottom. So you've got those kind of FOIL problems in the top and the bottom, or the double distribute problems. But you just have to keep in mind, it doesn't matter if you have a radical in the top, it only matters if it's in the bottom. Y'all got that? Try this one. You try this one. Then we'll do it together.
Square root of 2.
5 plus square root of
What we
2.
did plus?
Yeah, I
did
got
minus.
plus, but
You got to change. If you don't change the sign, the radicals aren't going to go away.
Oh, it gotta be opposite every time?
It's got to be opposite. It's got to be the conjugate.
Oh.
So up top,
I got that far.
I got 20 plus
20
4
plus-
square root of 2.
good job. What'd you get on the bottom?
25 minus 2.
Yes.
Oh.
Got 23.
Wait, why do you get minus?
Where to here?
Oh, I see those two just cancel out, right?
Right.
Hold on.
Yes or no?
Yes.
Hold up.
Okay, hold up.
I ain't had feelings, but I'm talking to Jay Rich. But I think I got the concept.
wait, how'd you get
35
minus 2?
5 times 5 is 25. 5 root 2 and negative 5 root 2 will cancel out for you. And then you get minus 2. Any other questions about that one? Can I move on from this? Or you want to do one more? Hold on real quick. Hold on real quick.
Okay, the step before, like the very end,
This-
is
This
that,
one?
yeah, is the denominator always going to be minus? Like, is it going to be like 25?
Yes, because you'll have one minus and one plus, and a negative and a positive will give you a negative. So it'll always be minus here. Yeah.
Right, thank you.
Tanner, what was your question? You want to do another one?
Yes.
Okay. Ooh, here's a good one. Ready?
Is it hard?
Yeah. Well, not that
I
hard.
can't even do the easy one.
This is I'm doing one of the ones from your homework right now.
Okay, I'm gonna look at that. I'm gonna write that down.
We have homework.
Yes. So just to get you started, if you didn't know,
I got that one.
so you gotta do it to the bottom, and you gotta do it to the top.
And I get stuck.
Okay, well now they're just distribute problems.
Like the, you could do like a little square thing.
Like y'all learned it as FOIL.
You do the square thing.
What
No,
square?
Never mind.
Take the first term and multiply to everything in the second set of parentheses. 3 times 2 is,
6.
yeah. 3 times the square root of 10,
3 square root of 10. Is this supposed to be like really long?
yes.
Oh, square root. Hold on.
Plus 2 times the square root of 7. Oh,
And then it
no.
goes back.
Oh, okay.
square root of 70.
Yes, Ozzy square root of 70. Yes?
See, I asked that and you said no.
Oh, I'm sorry. I apologize. I didn't. I thought you were talking about should you multiply by that. No, you can't break square. No, you can't break 70
Then I knew
down.
what to do after. And I kind of got it, I guess.
But if you could, you would. Did y'all hear the question? Can you break square root of 70 down? You cannot break square root of 70 down. There's not a perfect square that goes into it. But if you could, you should. Does that make sense?
Is that our answer?
That's the numerator.
I have a question. I have another question.
Ask me.
I'm gonna do good for
Plus
it.
10?
2 minus 10.
Okay, I thought.
No, 4 minus 10. I'm sorry. Yeah.
What would happen if we just left it like that and there was simplifying to
You would probably lose a point.
After you get to negative 6, does the 6 just cancel out? And then you get negative 1?
What 6 are you looking at? This 6?
Yeah, the one on the bottom.
Oh, I don't know. I haven't done that. Let's see. 2 times 2 is 4. These two are going to cancel, and it leaves me with minus 10.
Why did they cancel?
I see what you're saying. Because,
Why does
all right, because this is 4 plus 2 times the square root of 10. This one is minus 2 square root of 10. And then this one is just minus 10. They're same thing but opposite signs, so they cancel out. They can't, these two cancel out because they're the exact same thing, but one's a positive and one's a negative. It's all, yes, because negative root 10 times positive root 10 is negative 10.
Will it always be negative?
Yes. Because it's essentially a difference of two squares. It's just in factored form.
And now we just need to put negative 6.
All right, so the question was, when I get to the bottom, listen guys, can I cancel the 6's out?
The square root of 7. No.
And the answer to that is no, because I could take a 6 out of these, but I would have to take it out of everything. This 6, if you think about your rules of fractions that I hope you do remember, when you have multiple parts in the numerator like that, this numerator goes to, I could rewrite it this way.
And then it'll just cancel itself out.
Now don't do this on your paper because this is long and boring, but if you think about your properties of fractions whenever you're adding with the same denominator, you just combine all numerators and put them over that same denominator. So if you took a 6 out of this one, you'd also have to take a 6 out of this one, and this one in order for it to be. So yes. Unless you can divide everything by something. Yes.
The denominator for when we modeled it, why would it be 4 by the
Because 2 times 2 is 4. 2 times the square root of 10 is 2 root 10. Negative 10 times 2 is negative 2 root 10. And negative root 10 times positive root 10 is negative 10. A negative times a positive is a negative. Other questions?
Is that it? Is that all we do?
Well, so we're going to use all these properties we just talked about.
No, I'm talking about like, is that
Oh.
the answer?
Yes, that's the answer. That's all you can do.
Okay.
So I show you all that because that's kind of background of the lesson today. We're going to use that, and I hope that you make the connection in the perfect square trinomials from yesterday after I show you this. But we're going to use these as we solve quadratic equations without using the quadratic formula. That's the last thing we get
My
to.
sister can still cite.
Oh, I'm going to show you your sister's video
Ew.
Wait, will
soon.
you go back real quick?
Yes.
Like, 2 seconds. Why would it be the square root of 70? For those,
It is.
Ah, it is. I erased too many. I'm sorry.
And then that's the answer.
Yes. All right, so when we're looking at quadratic equations, we've already talked about, and I really want you to make this connection. We have already talked about if you have something like this, you can solve that for x, right?
Yeah.
What's the solution? Or what are the solutions? -3 and 1, because you set each piece to 0, right?
Yeah.
But in its regular form of x squared plus 2x minus 3,
Write this down.
yeah, that would be hard for you to solve, right, before you knew how to factor. So what we're going to look at today are some equations that we can use another method, some quadratic equations that we can use some other methods to solve, okay?
Quadratic.
Quadratic's a power of 2,
Of the
okay? All right, I want you to think about something with me for just a minute, and we touched on this yesterday as well. We talked about some opposite operations. Whenever we solve equations, in other words, what makes things cancel out. And we talked about the opposite operation of addition is subtraction. I knew what you meant though. The opposite of multiplication is, and the opposite of an exponent of 2 is a square root. So in other words, if I had x squared equals 9, to solve that for x, I would have to do what? Square root it.
both sides.
Both sides.
And then the square root will cancel out on that one side. And then you'll be like
What does x equal?
3.
Close.
3, 2, and
Plus or minus 3. I got to I have to remember those plus or minuses because that's really going to come into play because we've been talking about whenever we solve for x, when it equals 0, we're finding zeros, we're finding intercepts. So make sure you include those. Now, before we get really complicated, I also talked about yesterday a special order that I was so shocked you never heard of that you solve equations in. Sad map. So remember,
It's MEP, not MAP, yeah?
when we simplify, we go PEMDAS. When we solve, we go sad map. Okay? I will also tell you, if you only see x written one time, let me say appears. Only once. Now, I'm not talking about exponents. I'm not talking about any of that. I just mean if you literally only see x written one time in the equation, you can solve using sad map. And I'll show you exactly what I'm talking about. For example, if I needed to solve that. Sad map. Addition, subtraction first. What's first? Minus 5.
36.
Okay? Because multiplication division is next. I hope this part's easy for you.
Well, and then you do the thingy.
You square root
You square root. What thingy are we talking about?
plus and
I was
negative.
talking about the other.
Yes, plus and negative. But when you see square root of 12,
It's just
yes. Simplify the radical. Always simplify the radical if you can.
What if you can't?
Then you leave it.
What if you
It's like
don't?
56, I'd be
You
like,
take off points if you don't?
Yes. Your directions will always say to simplify your answer.
What if we give you a take off points
Yes.
if you
Yes.
don't? Oh, wow.
And understand why the plus or minus is so important. Let's do another one. Let's see if you understand. You have a couple that look like this on your test.
What test?
Oh, good gravy. It's not tomorrow, no. All right, I'm going sad map. The thing to remember, and I know I can go sad map because I only see x written one time, yes? Does everybody agree? All right.
First, you multiply x and 3 by 5.
Yes. Shh, shh, shh. First thing I'm going to do. All right, let's go backwards. As soon as we get done with this one, we'll go down and watch WDOG.
You too want some chocolate.
All right. So, Coach Hendricks was wrong. We do not do the squared first. The last thing we do are the parentheses, yes? Because whenever I'm going in sad map order, that's the last thing. So whatever sits inside here is last, even though there's addition, subtraction in there, okay? So do I have any addition, subtraction outside of parentheses? No. I do have multiplication or division because I have this fraction, yes? How do I get rid of that?
So we 5x.
By 5 over.
Reciprocal.
Guys, I need y'all to pay attention. Last one.
And then it'll
By the
cancel
reciprocal.
out. It'll cancel that, the other 1/5.
Exactly. The 1/5 is gone from this side now because 5 times a fifth is 1. And it equals 35. Yes?
Would it always be, I mean, would it be the same, like, if it wasn't 1/5, if it was like 3/5?
Then it'd be 5 over 3. You still flip it. So now I'm moving on to exponents outside of parentheses. I do have an exponent, and yes, ooh, I almost called you Sophia. Yes, Juliana, I'm sorry. I am so sorry.
You do x square root of 2 and 3 square root of 2.
Well, you can do the whole side at one time.
Yeah.
Since that parenthesis is there, yes. So I'm going to go both sides. Ah, my pen just quit working.
What you gonna do to both sides?
Say that one more time. You can't do that, and here's why. Did y'all hear that question? I want to make sure y'all see this. The question is, why couldn't we just make that x squared plus 9? So anytime you see a plus or minus inside parentheses, you never want to distribute the exponent. And the reason is, multiply it out and tell me if you get the same thing. If I were to, because do you agree that's what squared means, is multiply it by itself? If I were to multiply this out, I'd get x squared plus 3x plus 3x plus 9.
Oh.
Which would be x squared plus 6x plus 9. So by just distributing the exponent, you miss that middle term doing that. So that's why we don't want to do that. And if we did this and we put it over here, well, now all of a sudden we're hard to solve again, right? However, if you look at the way this sits now, this x plus 3 squared equals 35, this looks like a factored perfect square trinomial. Because it's a binomial squared. Remember we're talking about those PSTs? Yeah. I'm sorry. Am I using too many acronyms?
Yeah.
Okay, I'm sorry. I'm sorry. All right, let's look back at the problem. Square root, gone, gone, yes?
Square root's gone.
X plus 3 is, don't forget this very important part, you will lose a point for that.
Don't assume that it's just positive.
That's right. The square root of 35, I can't break that down anymore.
Okay, so let's do the very last part.
But I'm still not solved for X, no?
What was 9?
Well, you're gonna have to subtract 3 on both sides.
Shh, guys, I need you to keep your attention. All right, I'm gonna write this. I'm gonna put the -3 first and do the plus or minus next, just because that's nice math manners to do it that way. It's not wrong if you write plus or minus root 35 minus 3.
Oh, God.
But this is just prettier math. Tell me what you think. Can you solve with radicals and use all the simplification properties that I showed you earlier to simplify your answer? Yes? Okay. Don't say that!